Welcome back to another video of RoboCNC, the plasma build. I'm Marcel. So in the last videos we built this Z-axis for the plasma. And the Z-axis, just like with the router build that we did in a different series of videos, is the up and down motion for, in this case, the plasma torch, or eventually even also a router spindle on this machine. Now, this, of course, just like with the router, also needs to travel along a gantry. And that's what we're going to build in this video. Now, I do have some fancy tools like this grinder or this hacksaw blade with a piece of tape as a handle. But still, cutting pieces like this, 6mm wall thickness, 250mm by 100 is quite a hassle. So I had to convince my wife that I need yet another tool here in the shop. Charming as I am, I went to my wife and I told her that I needed an Optimum saw, the S275N to be precise. And we went on the internet, went out to VDH Machines, which is a Dutch company, and my wife told me that's quite an expensive saw. So I want to thank VDH Machines for the discount they gave me in sponsoring this video. This is going to be the gantry of the plasma build. On the front of this profile I need to mount the HIWIN Rails that will guide the Z-axis over this gantry. Now, to drill the holes I need to mark a line, and this line needs to be perpendicular with the rest of the machine. So I could use the profile to draw a line on top of it, but not a welder guy, just welded these two mounting plates on the profile, and I was planning to use this beautiful straight edge to place it like this and then use the straight edge as a reference to draw this line. Now, when I was doing so, I found out that with the straight edge on my welding table and checking the tolerance, that I have a tolerance of only about 0.05 of a millimeter. And well, tolerance is called tolerance for a reason, because it is the amount you are tolerating to deviate from straight. And if you're building a Haas or a DMG Mori expensive machining center, that tolerance needs to be really, really low. But I'm building a plasma table. And eventually I will also put a router on there, and it will also be a router table. But I will be machining name signs, woodworking, stuff like that. I mean, even if this table was out of straight with 1/10 of a millimeter, I would absolutely tolerate that. So, change of plan. So I put the Z-axis on the gantry, and there's more friction than I like there to be. This profile started out his life as a plate, and then it gets formed to be a tube. And on the other side there's a welded seam, and that's not flat for sure, but this front seemed quite flat to me. But I do now suspect that I placed these linear rails and they are not fully parallel but slightly inwards. Now, professional machine builders grind these perfectly flat, so they place some flat bar on there and then grind it. But I do not have the grinder to do so. So let me think. So I measured it, and indeed these two bearings are not completely planar. They are in an inward angle. Ideally, I would grind this profile, so weld something on it and grind it perfectly smooth, but I do not have the machine to do so. I've seen people do it with thinned out epoxy and stuff like that, but really, if I put the Z-axis on here, it will ride on these outer edges for sure. And what I'm going to try is to shim these middle and inner edges. I measured it. It's not something to be proud of. I mean, this one is 0.15 of a millimeter, has a gap of 0.15 of a millimeter, and this one 0.35. Same on this side. So let me first try and shim it and see how this works. So the shim stock is in. It's not perfect, but much better. Time to do the next step, because the next step, this side is far from being square. So quick little recap. The side project is done. It's mounted, a stepper motor driving a grinding wheel and attached to the Z-axis. The Z-axis is mounted upside down, so in reality this side is normally the top side of the gantry. Now I'm going to run this stepper motor, thereby running this grinding wheel, and then trying to grind this top surface flat and square or perpendicular to these linear rails or to the Z-axis. So maybe you can remember from the Z-axis video that the Z-axis was controlled by a servo motor, but there was also some spring tension. If you haven't seen the Z-axis video, well, make sure to check it out. So I made a grinding wheel attachment. The grinding wheel will be run by a stepper motor, and I will do the linear action by hand. So the servo motor is going to get the grinding wheel close. Then I'm going to go against the spring tension and try to grind a flat on this top profile. So the grinding wheel is going to be driven by stepper motor. The stepper motor is driven by this stepper drive. The stepper drive is powered by a Ryden RD6024 power supply, which is 60 volts, 24 amps. And this cute little puppy over here is a Unity UTG962E, which is a waveform generator, and this will create the block-shaped pulse that will be the step signal for the stepper drive. So this way we can basically use it as an electric motor with a variable speed. So powering it on, you see it's running really slow. If I go higher in frequency, until it stalls. So let's set the voltage even higher. Let's have a look at the stepper drive, which is maximum of 80 volts. So I can go to 60 here, and let's see if we can drive it a bit faster now. Let's see what happens. Stall. So the idea was great, but stepper motor is not gonna kill it. It keeps stalling on me. It's quite a lot of inertia, so I thought when pushing it against the profile, the inertia will keep it around the same RPMs, and then I could start grinding with the torque of the motor. The reality is the disc is slowing down a bit, and due to the high inertia the high inertia of this disc, it's hard for the stepper motor to keep track on its steps. So it's starting to lose steps, and if a stepper motor loses a couple of steps, it just stalls. So, new plan. Seen in my last video that we were working with the ClearPath Integrated Servos from Technic, and these servos have positive feedback. So if it loses steps, basically it's going to put more current through the coils and try to keep up. So we'll see if this works out. So I took this one from the Z-axis. I'm now going to change it with this stepper motor, and to keep this from shifting, I'm using a different Technic product, which is the brake. I'm going to talk more about this in a later video, but I'm going to put it on the Z-axis and then make sure that the Z-axis stays stationary. So another clear win for the Technic servo, and I have now a beautiful ground smooth spot on top of the profile to mount the rack onto, like this. And not only it's flat, but it's also now perpendicular to the linear rails. So the gantry is now in its upright position. On the top side we see the ground space for the rack and pinion system. I took an angle grinder and also ground down the edges a bit lower so they don't interfere with the full rack. I plan to make the rack just the full length, which is not necessary. I could have just put it between here because the pinion will also be in the center of the Z-axis, but well, for aesthetics I thought it would be nicer to put the rack on the full length. Now to put the rack on there we have to do some calculations. We have to find a company, so I want to do that in a full new video, but since I already, it's the night after grinding, see small pitting in this glossy surface here, I'm gonna put some paint on it and then call it a day in this video. So let's put some paint on it and finish this profile. I planned to finish the complete gantry in this video, but we're already close to half an hour and there's quite a lot of detail that goes in this project. So next step is going to be the rack and pinion system. In the next video I'm going to show you why I go with the rack and pinion system, which one, what company, and how to select the correct one. So let's first do that. I will go get some rack and pinion, and then in the next video we mount it and see if we can get some linear motion of the Z-axis on the Y-axis. Hope you liked the video. If so, thumbs up, subscribe, and hope to see you in the next one.